Here we're going to look at the arc length function, which is a very important function in applications in physics, engineering, and it's going to crop up again in Calculus 3. We notice that if we have an equation y equals f of x, and if we draw the graph of that function, and suppose we start at a point a, f, a, and we stop at the point x, f of x, then the distance we've traveled is a function of x, and that's called the arc length function. And how do we find a formula for that function? It's going to be the result of applying our formula between a and x for the arc length. Now, to apply the formula, we need to use x as an endpoint for the integral, so we're going to allow our x-axis to serve as both an x-axis and a t-axis. So for the purposes of calculating the arc length, we're going to call this curve y equals f of t, and we're going to calculate the arc length between a and x, where the t values run from a to x. So the arc length between a and x is going to be the integral from a to x of the square root of 1 plus f prime t squared dt. And this is a function of x, and it tells us the distance we have traveled when we get to the point x, f of x on our curve. From the fundamental theorem of calculus, recall that we had the integral from a to x of f of t dt was an antiderivative for f of x. So in this case, this function s of x is an antiderivative for the function the square root of 1 plus f prime of x squared. And now you see that the derivative of this with respect to x is the square root of 1 plus dy dx squared, and in the language of differentials, this means that the change in s squared is equal to the change in x squared plus the change in y squared at that infinitesimal level. So this is a very important formula, and you'll get back to that in Calculus 3. For the moment, let's just content ourselves with actually calculating this function and understanding what it means. So suppose I'm moving along the curve y equals 2x to the 3 over 2 over 3, and I start at the point 1, 3 over 2. When I get to the value x on the x-axis, how far have I gone? Well, I'm going to apply this formula. It's going to be the integral from a to x of the square root of 1 plus f prime t squared dt. And we have the derivative of our function is the square root of x. So f prime of x is the square root of x, so f prime of t is the square root of t. And the distance I've traveled at the point x, f of x, is the integral from 1 to x of the square root of 1 plus t dt. Now when I substitute u equals 1 plus t, I'm looking at u to the 3 over 2 over 3 over 2 evaluated between 2 and x plus 1. So the formula for my arc length at x, the distance I've traveled from the point 1, 3 over 2 when I get to x on the curve, is 2 times x plus 1 to the 3 over 2 over 3 minus 4 times the square root of 2 over 3.